The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Why did I think making a digital rat's nest was a good idea? Thanks, Felix. This reminds me of the time that I tried to build a slot-loading Nintendo on the show. The cartridge was gonna go in automatically, just like a CD player, and it kind of worked, but it was also kind of a nightmare. What would I do differently now? Well, for starters, I just wouldn't do it. But that's water under the bridge. Today's episode, we're gonna look back at that project and analyze what we should have done differently and the challenges we had along the way. Let's get started.
Amazing hacks.
How can we make this portable?
Inspired designs.
I am the internet troll.
Regrettable acting.
Batten down the hatches!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
The larger cartridge in the slot is mostly for show. The cartridges themselves are mostly empty. This episode must have been filmed in early 2013, but it seems a lot longer ago than that. Once we started doing 4 episodes a month instead of 2, it seemed like it became a lot harder to keep track of them all. The Nintendo Entertainment System first came out in Japan in 1983. It was called the Famicom, for Family Computer. Nintendo then brought the system to America. But by that time, the video game crash of 1984 had occurred, so Nintendo wanted to differentiate their console from the current consoles, which the Famicom looked like. Storytelling like this is fun. We don't always have time for it in the schedule, but when we do, I feel it makes for good content. Here's how I'd like my system to work. You insert the game by hand, and it trips a pair of IR sensors, which tells the console that a game has been inserted. At that time, there are 2 friction wheels on either side of the cartridge that pull the cartridge into the console, so you don't need to be pushing it anymore, toward the connector. This is a really good example of setting up the project ahead of time. If only it would have been this easy to build. Here's an extreme close-up of the connector. We have the PCB here, card edge connector inside of the cartridge. We have a pair of jaws with Molex pins on them. What the jaws will do is they'll clamp down on the cartridge once the cartridge hits a limit switch telling the system that it's inserted all the way. So instead of pushing the cartridge into some jaws like that, we're going to clamp the jaws onto the cartridge like that. This is the kind of project we try to avoid now. Complicated things with a lot of mechanics that don't serve a real purpose. Like crushing cans, that's a real purpose. It came with a free copy of Mario Brothers and Duck Hunt. Score. I've learned since this episode that even common Nintendo cartridges fetch decent money these days. Stuff like Contra or Mike Tyson's Punch-Out are worth $20 or more. Less common games from later in the system's life can fetch close to $100. Taking things apart on camera eats up a lot of screen time, but it's an important part of telling the story. We could show every little detail, I guess, but then the episodes would be incredibly long and take much, much longer to edit. It's not just the time it takes to film something, but also the time it takes to edit it. Like the cartridges, old working Nintendos are worth decent money. Partially because so many of them fail due to poor cartridge slot design. It's totally fixable though. The newer Nintendo, the top-loading one, just has a regular, cartridge slot, so it works better. But then it omits the nice composite audio-video out, so just can't win them all. It was very progressive of Nintendo to have composite video in 1985. Most TVs didn't even have composite video inputs until the early 90s. To disable the lockout chip, lift up pin 4. It's normally connected to 5 volts. Now we're going to connect it to ground. That will disable the lockout chip and severely reduce the number of gray screens you get. I wish we could go into more details on things like disabling the lockout chip, but in the grand scheme of this project, it's a very small step. You could easily spend 3 to 4 minutes on that step alone. Now this is actually an Xbox 360 video cable. And they're kind of useless now, but I keep them around because you can get nice shielded cables out of it, which I can use on things like this Nintendo. We try to recycle old parts we have laying around. The sad reality is they pile up faster than we can possibly use them. Hey, it's not our fault they include VGA, DVI, and USB cables with everything. And then we're going to attach a wire to this resistor here, which will give us mono audio, which we can mix into both channels just to give it a little bit of, just to fill it out a little bit. Oh, so I thought we'd be able to fit the slot loading mechanism inside the Nintendo? Wow, I was wrong. Things like this can prolong a project, starting it off one way, but then having to start over when you realize that won't work. Like, oh, this will never fit inside of a Nintendo. Back to the drawing board.
So instead of pushing the contact into it, it pushes down onto the contacts on the card edge connector. So I've got to hook up, I don't have to hook up all 72 of these because the Nintendo, you can't really see it, maybe you can. The center connections don't go into anything.
This is bringing back bad memories. I think it took 3 to 4 different methods to finally get this cartridge connector to work. A lot of wasted time and parts, and for what? Something that looks cool. The best projects are ones that I'm excited to finish. This project was a slog and a half. This was, without a doubt, the most time-consuming project we've ever done on the show. I'm not really exaggerating here with my frustration. Battletoads and Double Dragon cartridge, shown here, is one of the less common later games that is worth more money now than when it was new. I should have experimented with a cheaper game, but at the time, I didn't realize how much it was worth. But it's still okay. And there's a top portion too, which keeps it all solid. So this is the main loading mechanism. The loading mechanism worked quite well. It was the cartridge contact clamping that really fouled things up. We should have used steppers instead of servos. If you do anything wrong with servos, they can burn up pretty quickly. This must have been before we built all of our custom AVR dev boards. It's the only explanation for me wiring this manually. It's fun and relaxing to wire things, but it eats up a lot of time. PCBs are expensive to make, but if you waste more time wiring than a PCB would have cost, you probably should have gone with a PCB instead. Seems to work pretty good. And Mike came out in a hurry. It's just fun. I'm excited here because this part is working well. Later, this excitement will turn to tears as I try to make the cartridge contacts work. That's a whole nother ball game. All right, I'm still working to make the cartridge slot function correctly. I've got a new plan of attack. I've got some of the 3D printed parts from yesterday. I'm using wood to block them off to give them a little more rigidity, and I'm gonna put them into this frame and see how that works. But I'm not gonna stop until I get it to work. So this is failed attempt 1 or 2 or 3 on making the cartridge connectors work. It requires a good bit of force to make constant contact. Normally you'd feel this force as you press a card edge connector into something. Replicating that force with motors is no small task. Attempt number 2, using laser cut wood to apply force on the contacts. This didn't work either. In normal projects, you'd go through several revisions like this. For us, we can only do so many before time runs out. This did work, but the servo burnt up shortly after we finished the episode. If you make a servo go past its limits, it will eventually destroy itself. Something like a stepper motor plus some gearing would have been a better way to achieve the holding torque we needed, but at this point we couldn't make that major of a change without completely redesigning the mechanical aspects of our project. The metal tines, not times, were very difficult to keep straight and at a constant height, since it was all built manually. I guess if I did this project again, I would know what not to do, which is usually more important than knowing what to do, if that makes any sense. Looking at this, it's laughable that I thought it might fit inside of an existing Nintendo shell. Oh, 2013 Ben, so dumb. All right, so here's how the system works. I have one of the microcontroller lines hooked up to the reset line on the Nintendo. This is probably the same crappy LCD I ended up using in the Apple I replica. A fuzzy composite screen is fairly useless nowadays. Plus this one uses far too much power, but it's good for experimentation. Yeah, got you, Goomba. Whoa, got him. At home, I still have a NES and a SNES hooked up to my living room TV. It's kind of funny, as the TVs get bigger, the older games look crappier. It's really NTSC Composite's fault, not the system itself. Oh, I put those pieces in backwards. There's your problem. Man, I really needed a haircut when we shot this. It was a very busy time of year, so that was probably the least of my worries. This was a 1-episode project that went over schedule and ended up taking 3 episodes. Epic planning fail on my part. A lot of work went into this project, which makes it all the more disappointing that it didn't turn out as well as it could have. We look at projects like these as red flags. When we come up with ideas nowadays, we kind of know what not to do based off how many projects we've done in the past. Things with a lot of mechanicals or programming tend to be more troublesome. Some tough projects still slip through the cracks though without us anticipating it, like the recent Xbox One tablet. It turned out good, but there's so many more steps we didn't realize that we had to do along the way. I hope you enjoyed this stroll down memory lane to one of our most difficult projects ever. Things I would do differently? Well, I wouldn't do that project. For starters, it was just too complicated with not enough reward. What about you? How do you feel when a project doesn't go the way you want it to? Do you ever give up halfway through? Or what do you do to soldier on and finish it? Let us know on the Element 14 community. We'll see you then. No! He's going crazy! The inhibitor chip, gone. Oh no, the smasher tube thing! Old working Nintendos are Otho? I am Shakespeare. You've gone too far! There we go. And then it is time to die. Looking at this, it's laughable to think that I might have thought it was. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.